Should be live now if everything works out to plan. So yeah, I applied this blocking partner label so that we can sub-prioritize or 3-0 things, because there tend to be too much stuff in it, and some people suffer priority starvation, where we just have people in the room that only care about their stuff, and then the other stuff is never being looked at. That's the thing that Mahoney suffered, like, I think, for like 3 months, I think. So we should finally take a look at this PR that was ready, like, basically.
But we have her in the room anyway.
I'm all the buttons.
All right, let me just copy the URL so I can read on my own screen as well. All right, do you want to walk us through it?
So can you scroll down a little bit? I just want to see if it does include that other. Yeah, it does. So, okay, so there's 2 APIs then. When I opened the issue there, I only proposed 1 API, but the second API was requested by another issue thread. So the GC.GetMemoryInfo one is basically just something that I exposed to BCL as an internal API before, but obviously this is useful to everybody else. It gives you a list of things that they're all there. So first of all, it's a read-only thing, as you can see first, and some of them are like, for example, the first. Sorry, if you scroll up a little bit, you can see the top. Yeah, so the high memory load threshold, that's something that right now, as soon as the process starts, it does not change. But we might consider providing an option to change it, while the process is running. And the other ones are the numbers the last GC saw. So for example, memory load, last GC saw memory load as 50%. Total available memory, again, whatever the last GC saw. Same with heap size and fragmentation.
Are these measurements generally in bytes, like total available memory?
So total available memory, heap size, and fragmentation are all in bytes. Memory load is in percentage, so it's 0 to 100%.
Oh, I see the comments there. Should we include bytes? Okay.
Yeah.
Got it.
And then the threshold is the same. It's also the 0 to 100%.
Yeah.
And the reason, sorry, that it's an end is because normally we get these from global memory status X, which returns memory load as a 0 to 100 D words.
What does it mean for fragmentation to be in bytes? What is that number actually returning?
Fragmentation is the sum of all free objects on the heap. That's what we call fragmentation.
And this was as of the last collection, correct? Because that's the only time you could ever know that.
These are all like last GC, whatever the last GC saw.
Sorry, fragmentation is the sum of all objects on the heap?
All free objects.
All free objects?
Yes.
Is that, okay. That seems like an internal nomenclature leaking out. Like I wouldn't expect that's what that concept would be.
This is just what I've been calling it for the past, as long as I've been working on GC.
Yeah. Does it not include things where the entire page or segment or whatever you work with is considered free? So it's of active GC areas. What's the free?
So the reason why there's this concept is because if we don't talk about pinning for a second, right? If there's no pins at all. When you compact the heap, these are the free. Let's say everything else survived, right? Every non-free object on the heap survived. These are this number is how much you can get back. So that's why it's significant.
So, but this is only if the last collection was a Gen 0 collection. This doesn't include dead objects in Gen 1 and Gen 2.
Right, but you can then choose to say if you say so the example usage would be like, oh, the memory load is quite high, but probably not high enough to high threshold, that you told GC, right? So, what if, you want to do something, you want to react before that. So you could say like, hey, here's the total available memory, and this is my heap, total heap size, and looks like to be a significant fragmentation of the, the used memory. And then you can say like if fragmentation is also a significant percentage of that, I may choose to do a compacting Gen 2 so I can get that much space back.
Yeah. Is this for ASP.NET?
Right now, they are one of the people that are asking for it. Yes.
Is there a scenario in which the GC might change in some future version where these properties are no longer populated?
It's very unlikely because these are all things that GC calculates, and all we do is like, at the end of the GC, we just say like, let's put these numbers there, and you can get it if you want.
Okay.
Yeah.
And then the call to get GC memory info gives a snapshot, right?
That's what the last GC saw.
Right. So,
right.
So if you hold this struct and you keep reading it over time, you get the same answer every time.
If no GC has it, exactly, yeah.
So today there is no any other way you can use this.
So memory load, you can get sort of a if you're using hosting API, which almost no one does. I mean, I do know of one team that does use that, but yeah, almost no one does. Heap size, you can not this heap size. You can call it get total memory. GC class has another method called get total memory, but that's sort of heap size minus fragmentation. So you can get that, but it would be nicer if you can get both heap size and fragmentation to know what the actual heap, like how large it is, and then you can say like, oh, if I did a compacting Gen 2 GC, this is how much I can get back. So.
And also to clarify your points, the GC memory info is not updated in place whenever a new GC happens, so it's going to be like snapshot.
Because it could be the struct is representing a cursor, but no, it's a point in time. Yeah.
So, just to clarify, the fragmentation is the free objects only in the generations that we collected, and the heap size is the total heap size across all generations.
No, this fragmentation is actually total fragmentation on the heap. Just because GC is not collecting that generation doesn't mean GC can't know the fragmentation in other generations.
Okay.
Yeah.
The question is, do we need to have a new struct for GC memory info, or it can be like static properties on GC itself?
Well, what's nice with making it a struct is that it's clear how these relate. Like if you make them static read-only, then as soon as you query them, you get them in, they're no longer snapshotted as one unit, right? You get like one data point at 1 second, another data point another second. They no longer correlate to each other. You no longer have an atomic read, effectively.
How expensive do you think it would be to actually populate the struct? Like, do you already have all the information right there, and it's just literally mem copying the fields?
Yeah.
Okay.
Yeah, there is a pull request implementing that. It should be linked at the end of the very small.
Yeah, so like in terms of like comments, like the comments that are in the code, I kind of agree with. Like I think percentages in our case are usually floats between 0 and 1, because that's basically if you want to format them with string format, like that's effectively the value range we expect to basically put it into percentage.
Yeah.
Quite frankly, whether we suffix them with percent or not, I don't think makes a huge difference, because threshold and load kind of percentage in nature. But the other ones, I would honestly say I would suffix them with bytes, because especially like fragmentation, that to me sounds more like a percentage than it sounds like a number of bytes. So like if you say, I don't know, like total available memory bytes, total heap, heap size bytes, and fragmentation
Normally
bytes.
I would call it fragmentation ratio if I want a percentage, but that's just my personal, Also, another thing is, I mean, I have absolutely no objection if you think there should be byte at the end of it, but normally, like in Purview, for example, where we deal with these numbers all the time, I think if you don't say byte, it means byte. But if you have like megabytes, obviously you say megabytes. But make it more clear.
Yeah, I think the clarification is just whether it's a unit of memory versus a non-unit memory. Like, it's not we're clarifying bytes versus kilobytes. It's that we're clarifying bytes versus percent or bytes versus something else.
Yeah. I think both of the percents either need percentage or ratio, because certainly when I first looked at the word threshold, I thought it was an absolute number.
But if we change it to a floating point number, like the return type, presumably indicates percentage or ratio.
No. Floats are bigger than ifs.
They can be bigger than int, but they're not necessarily precise.
Well, it's not necessarily that they have a range bigger than int. It's that, like, if you're using a float, it's because you wanted to return something that could have.
Yeah, but
decimals,
I still
basically.
think that adding ratio or percentage is.
So how would you call the first one then? High memory load threshold percent?
But can you define exactly what this concept is?
Oh, it's just, let's say you have, 8 gigs of memory, you've used 4 gigs in physical memory. That means your memory load would be 50%. And the high memory load threshold is a threshold that GC considers to, now you've entered high memory load situation. So normally this is about 90%, but you can use a config to change it.
So it's basically when we more aggressively GC.
Sorry?
That's when we start to more aggressively GC.
That's when we start to more aggressively consider doing Gen 2 GCs.
So this number could exceed 100%.
No, it's 100% is max.
Yeah.
Then
You
out of
cannot
memory.
use more than, memory load is,
Well, but the high load threshold.
that wouldn't make
If you're
sense.
if you're in high mode, you just return 100.
I mean, if you specify a number that's more than 100, we'll just cap it at
No, like so basically what this indicates is like what is the percentage of memory usage that the GC considers high memory load? Is it 80%? Is it 90%? Is it 95%?
So if you
See,
set
I
it
thought
in
this
the-
was how close we were to hitting the high memory state.
No. Threshold usually means like a number that you consider something as, when over.
And I think the normal for our existing .NET APIs is to prefer double overflow.
Yeah, we never use float except for when
if we do name the property percent, we just need to normalize it to 0 to 100. That's all.
I think it should be normalized between 0 and 1 because for precision purposes.
Oh, I agree with that. We just shouldn't call it percent if we do that.
What do you mean?
The term percent literally means baseline between 0 and 100.
Yeah, so it would be ratio.
Fair enough. Like you can call it factor then, or like I don't know.
Well, although I think a lot of people who work with doubles and floats, regardless of what percent normally means, will expect a value normalized between 0 and 1, and we could document this is normalized between 0 and 1.
It's 100%.
Well, I mean, to be clear, like, I mean, in the BCL, if you string format something and you say perform it as percent, we expect the value between 0 and 1. We don't expect the value between 1 and 100.
But it's formatted as a percentage.
Yeah, because we multiply it by 100 and then put a percent.
Sure.
at the end.
So how do you call the underlying value then? If you don't call it a percent.
Right. So for percent, we consider 1 to be 100.
For formatting purposes, yeah.
And for other purposes, and I think like system drawing works the same way.
Yeah, I guess my question is, what do you call the input to the string format then that would be formatted as percent? Would you call it a factor or a ratio?
A factor, ratio, whatever.
Yeah,
Just
I'm fine
1%.
with that too.
Because a ratio would be as a thing over another thing. So since this is a usage over the limit, that would be a ratio of the threshold.
Yeah.
I'm also good with threshold.
Yeah, I mean, I guess once it's a double, and especially if we put a byte suffix on the other things, then
So what do you want, double or float?
double. We never use float.
Excuse me. Yeah.
Decimal?
Decimal.
Yeah, no.
That's big decimal, yes.
Okay, so then, and so what's the name then? High memory load.
By the way, this might create some confusion for people who actually use that config, because in the config we specifically say this number is specified between 0 and 100.
Maybe
Zero
it should be an
and
high memory load setting. I mean, like then it's go see the high memory load setting. Like it's just telling you what the GC was configured as.
So you're really just reflecting this number that's read from config back out to the user then?
So if you don't specify a config, we have default.
Okay.
Right. If you do, then it's that number you specified.
How do we call it in the config?
High memory threshold, something like that.
Because I mean, maybe we should just have the same name that we already exposed in the
Let me
config
quickly
then.
check.
And the config has to be an integer?
And
It's an int.
There's another plan to actually be...
Yeah, if the config is an int, then I would say just return an int here as well.
Yeah, just reflect exactly what came from config.
For the high memory load threshold, there's another API proposal that's proposed to be able to change this value. So,
well, in which case I would expect people would be inputting an int there as well.
Oh, well, actually, the
yeah.
config is called GC.GetMemoryInfo.
Which, number between 0 and 100.
Where do you even see this?
Huh?
Where do you even find this?
I asked Ron to document this, and he said it's going to be in
it's
the
not
next
documented.
month or
I see.
something.
I see.
So.
Yeah, and if we're gonna if we might support setting it in the future and point values don't actually do anything because we're not going to like say 61.5% and then actually treat it as 61.5%. We'll treat it as like 62 or something. Then I think just an int between 0 and 100 makes sense as well for that.
So it's called high memory percent, you said, right?
Or
GC high mem percent.
Okay, I guess high memory, we should probably spell that out.
Yeah.
Yeah, high memory.
And then, okay, we say it's high memory percent and we say it's an int, okay?
Yeah.
Memory load seems like that properly should be a double.
Yeah.
Because we're dividing two longs together effectively.
Seems a bit confusing that there would be a high memory load percent, which is int between 0 and 100, and then you have memory load, which is comparable, like the same kind of comparable value,
Yeah.
but it's a double between 0 and
You could make the argument reasonably that one of them is literally just being reflected from config and one of them is being dynamically computed at runtime.
Sure, but they...
Yeah, except the config is so buried and so non-discoverable compared to an API that's so prominent.
Right.
That's fair.
Is this prominent?
I mean,
He's under
I
system.
think so.
Okay.
Well, and 0 to 100 for this is probably fine because I don't think people are going to be wanting more than like 3 digits of precision anyways, in which case the floating point rounding error is not going to matter.
So how you would use that number though? Presumably you would use it in a computation, in which case the very first thing you would do is divide it by 100.
The way it's already used in CoreFX is by comparing basically memory load and the high memory load threshold, and saying that the high memory load threshold is kind of an absolute value that you use, and you say, if I am at 80% of this high memory load threshold, then I'm under high memory pressure, for example.
Right.
That's how I'm going to reduce the caching, reduce that. So you really use memory load and compare it to high memory load threshold.
Yeah, in which case you really want to be the same metric, otherwise like...
Well, I mean, if it, yeah, you want them both 0 to 100, but I don't think you need both float or both int, because if you've got one int, the other double, then the int will implicitly convert up to double.
Right, it just seems odd. I mean, like, honestly though, like, I don't know, we could say the value is float still or double.
So
And then just
there
say
is merit in making the, keeping the memory load threshold as an int, but making the memory load as a double. Because when you specify something, you probably don't need to say like, wow, like I have to, instead of 90, I want 90.1. It's fine to say just 90.
Yeah.
But if you have a lot of memory, like 120 gigs, 1% is a lot. So you could, like for small processes, you could want this to be a double, so you can get like very precise numbers.
But are you computing it with high precision, or are you computing
I
it as
can.
two?
I mean, I can.
Fair enough.
So, and this also allows us to change it to compute precisely, right?
Yeah, I don't have strong preferences. Like, I would generally say, like, I would try to make APIs look like similar. I mean, there seems to be no downside to making it a float. I mean, like, yes, it's a bit questionable whether you ever return the value, but it just seems odd when you look at the API. One is an int, one is a float, but they're both percentages. It's just that's odd, right? Like,
well, why not just return the absolute number instead of a ratio?
You could. I mean, like, that's the other thing, right? We could just say memory load is always an int, but that also seems weird, right?
No. I mean a long. It's literally the number of bytes that is the threshold.
You
That's
just ratio
fine,
it against total available memory yourself.
Yeah.
What about the case where you have hot pluggable memory in your system?
It will get
Again, it's a
updated
GC
dynamically.
snapshot. This is what the GC considered available and what the GC considered in use.
Yeah, because this is a immutable struct. You wouldn't use a struct to go set properties on the GC. And maybe if we had a way to modify the GC at runtime, then that would take a double or something.
So whatever we want for this top guy, and then the memory load should be the long, and then put bytes on the end of everything so that we understand. Except the top one.
So memory load would show me also.
I mean, the top one
right?
could be bytes as well. But normalize literally everything to bytes.
Could.
Say like when we detect this many bytes or more in use, we trigger a GC. When we this was the memory load in bytes when the last GC occurred, and so on. And then you have all the information there available to you if you want to do your own ratios. That way we also don't have to worry about float versus double. Even though double's clearly right.
So, okay, so it means everything is long, everything is suffixed with bytes. Okay, let me write this down.
I mean, GC team, does that seem reasonable?
Hmm?
Just normalize literally everything to bytes and expose no ratios through the struct?
The only thing would be if people did specify the config, they might think it's, I don't know.
Well, but config says percent and this doesn't. So
yeah.
So this is your interpretation of the config setting is this absolute number.
I don't know. That's why you guys were here.
I think it makes, like, if everything on here is long and bytes, I think it's easy for somebody to go back and get the percentage if they want, and it's better than if we have int percentages compared with double percentages compared with long total or absolute value. So
also, yeah. So I think that right. I think you guys think that APIs should be more like prominent, like in how people use the framework. But I think people on the runtime side are really trying to push for more configs. Well, more configs that make sense anyway. The configs will be, I imagine, like documented, talked about, and so,
and never changing.
I heard from Rich Lander that we the compatibility bar on core doesn't seem to be the same as on desktop.
Yeah.
Well, that's different for APIs. That's the thing, right? So it's one thing to say that the compatibility bar isn't a big deal. So from a config perspective, we might change configs from release to release. But from an API perspective, we ship an API and that's it.
Okay, so you're suggesting that I'm
suggesting there's a reason we're thoughtful about adding new APIs and what we name them and whatnot, because...
I completely get that. I'm just also, I completely understand we need to be thoughtful to adding new APIs. I'm just saying that configs are also sort of, probably not up to the API standard, but configs are not like, we're at least trying to make them not like completely hard to discover. We are trying to make them, to the, stand like in a place where that's discoverable too.
I think that makes total sense. That's goodness. Discoverability there. The path I thought you were going down was, well, we're making our configs more prominent and we're documenting them. Therefore, we should have like equivalent APIs for all of them. And
I highly doubt that's going to be the case. So.
And Melody, if we make the high memory load threshold bytes, how do we compute it back to a ratio, to a percentage? Like, how do we compare it?
So we know the total available memory, so that would be the percentage of total available memory.
Okay.
Yeah.
And I imagine that if you exposed an API that allowed you to change the threshold at runtime, that would probably be a %. That way the user wouldn't have to know the current memory available.
Because you're changing config at that point.
Yeah. Right. Yeah.
So bytes all the way down the board then?
Seems like it. So the other thing is GC memory info should probably be marked read only, right?
Yeah.
Would be my guess.
Unless we do, I heard someone say that we might have the ability to change the threshold, and that may even be settable.
Well, but this would be a snapshot, though.
Right.
Yeah, this would be a method on GC that would allow you to change it, presumably.
So okay. Maybe we should call this snapshot or something then, because it is a point in time recording.
I mean, honestly, the API gives you that already, right? I mean, you call it method, you get back the struct. I mean,
yeah, if it's read-only, that's conveyed.
At the time of the last GC.
Okay, sure.
I still, if I'm the only one, then I'll stop mentioning it, but I still have trouble with the word fragmentation for the concept it actually conveys.
How would you name it soon?
It sounded like it was free bytes.
It's not a memory that's immediately free, though, correct?
Right.
Freeable bytes or something.
Freeable.
But that's incorrect though, because there could be other freeable bytes. We just haven't discovered them.
So
next time we do
these are
GC.
dead objects.
Right.
No, but it was
these are free
freeable.
objects. That's very different. So if I have a heap that that's like 1 gig, right? I have 500 megs of free objects right now, and next time if I do a compacting Gen 2 GC, I will likely get more than 500 megs back, because aside from the 500 megs, I still have other objects that wouldn't survive.
But at the time of the last GC, it was accurate, right?
So, sorry?
At the time, if you could have atomically computed the number, it would have been accurate at the time of the last GC. Is that true or false?
But last GC may not be a full GC, so I couldn't have computed that number. All this is saying is that this is the this is the minimum of space that you can reclaim if you were to do a compacting Gen 2 GC.
Is free objects the name that's used like within the GC and within the documentation to describe these?
Well, documentation, I don't know. I don't know if we document.
It's the name used in SOS, for example, right? Like that's what's printed out in the heap dump and whatnot.
Yes.
Maybe we should use the same terminology then. Here.
Yeah.
Free object bytes.
Yeah, but that could create confusion.
But it's also a min, right? It's like, doesn't that also need to be in the name?
But free objects, some people could interpret that as like sort of freeable as stuff didn't survive. That could be freeable.
Right.
Sure, but fragmentation could have a whole lot of other meanings as well. I mean, my mind goes to things like fragmentation is the percentage of how much of the heap has gaps in it, or things along those lines.
That's exactly what it is. Free objects are gaps. If you understood it that way, that means you'd be correct.
Right. So
so would it be then fragmented bytes? Is that?
I mean, you can call it fragmentation bytes. I'm okay with that.
If I have some objects that have become dead in generation 0, and I call GC collect 1,000,000 times so that it actually does things, are the bytes in there counted as fragmented or not? Given that there's now nothing allocated in Gen 0.
If you only have Gen 0, let's say, and you have free objects.
So I had some objects, they got unrooted.
Yes.
I called GC collect a couple times.
Right.
Is fragmentation 0 or some other number?
If there's no pinning, that would be 0, likely.
Okay, so if the entire
not guaranteed.
If the entire generation heap has become completely unused, fragmentation is 0. It's only about objects that haven't gone to the inputs. Like they're in the middle.
So it's not. That's why I'm saying it's not good to call it freeable, because now you just implied something to do with lifetime.
I think the question was, let's say that you have objects A, B, and C on the heap, and then you've got a bunch of memory that's free, never been allocated on the rest of the heap.
Yeah, that's not part of fragmentation.
Yeah, that's not part of fragmentation.
Yeah. Okay.
Yeah. It's only like if you free
it's a
B.
gaps. It's like what Steve said.
So if you freed B, then B would count as the fragmentation since A and C are still alive.
Right. So if you have something like this, right? So this is my free objects. This is object A. B. So fragmentation would mean this.
Yeah.
And you can, if you did a GC, you could come to this situation because we may not have done a compacting GC. But if you were to do a compacting GC, which you can induce via one of our APIs, then these would become like this. Object A and object B. So this part is gone.
And then the rest of it's free memory, but not fragmented memory.
Exactly. Yeah. Right. So this is on our segment, right? This is our ephemeral seg. So this part, that's not part of fragmentation.
Yeah.
And so on the first thing, what is memory load? Is it 4 slots or is it just object A
So
and B?
memory load is kind of different. Memory load is a physical memory load, which may, let's say you touched all the pages that your objects are on, then it would be this divided by available memory.
Okay.
Right. But of course, you could be in a situation where you have a very large object, you haven't touched all pages. Then it would only be touched pages. Because it's a physical memory load, right? It's not committed bytes.
Oh, right.
Yeah.
So if memory is dropped out, it doesn't count in the memory.
Right.
Okay.
Yeah.
What about reclaimable or something like that? Is that at all accurate?
I think that's just because like fragmentation, there's a very accurate meaning to it. Reclaimable could be, I don't know. I don't even know how people would interpret
fragmented bytes sounds like the picture.
Fragmented bytes.
It sounds like the picture you drew on the board.
Yeah.
I guess. I'll drop it. For me, I hear fragmented, and to me it sounds like something about the bytes themselves are split.
So,
I think if you talk about memory, that's, in general, that's not really how people...
Stefan, if I understand correctly, what you mean is memory that is not usable because it's too small to be, like, the gap is too small to be reused, or is it even something else?
Yeah, that, or I guess part of my problem is I think if like I hear fragmentation, and I think 59%, because it's like how fragmented am I? What? I don't know. I'm having trouble. I'll drop it. If other people have no problem with it, like.
To be honest, that seems like something where documentation would help, right? Because it seems like this is something where you kind of have to do what Mahoney just did, right? Like.
Yeah,
you just draw a diagram and you have to explain it, I think.
The picture
anytime I go to
on the
use
board.
I'm going to read the docs.
Yeah, I don't think Steven can see the picture
I'm
on the
writing it in
board.
chat.
But the picture that Mayoni drew on the board is exactly what I think of when I think of fragmented
Yes,
bytes.
yes.
It's
Yeah.
how much memory is in the middle of other stuff, and if you that you wish that these were squished together so that you could, if you wanted to allocate.
So
10K,
there's
you're
also,
like, oh,
I mean,
there's a
I
hole
can
right
also
there.
understand what
Well,
Steve
because
was
that's what the
talking
disk
about.
defag does. Is like this file is broken up into like 12 segments.
The free bytes here, they're totally considered for allocations.
Yeah.
Right. I mean, we're not just saying, like, oh, because these are free objects, we're just gonna not care about them anymore until next time we try to like squeeze them together, right? But these are like, no, next time if this is Gen 0, you call new something, we would totally see like, can we fit it here? If we can, we'll do that before we extend the end of Gen 0.
And
So,
if, for example, you allocate an object which takes like 1.5 of this memory.
right, so this would be made into one free object.
Okay. So you may still have fragmented bytes if you allocate an object which is a bit bigger than the one, like the free one you had before.
So the biggest object you can fit here is this big.
Yeah.
Right?
But if you fit an object which is slightly smaller.
Yeah, so then this would be made into free.
Okay.
Yeah. So then we repeat that. Like if we're still in the allocation code path and you allocate another object that could fit here, it'll be fit here.
So you can still get to a point where you have only one word of memory between the newly allocated object and the next one, so that would be in the sense fragmented because you couldn't allocate even a...
That would be a sense of fragmented that you are describing.
Yes.
Exactly.
Okay.
Yeah, right.
Yeah.
All right, so then I think let's just look at the last method you have here, which is the
Yeah.
get total bytes allocated.
Right. So I actually didn't, yesterday I didn't know, remember there's a precise argument. So the precise tells us if we want to suspend the E or not. Yeah. So basically this gets, so far how many bytes have been allocated in this process.
Do you think that people who are calling this in general are going to pass false?
So there's a long thread where people are discussing this. They're like, I believe the stronger side was saying like they would call it with precise. So true, they would want, they didn't mind to suspend the E. This is used in some sort of like benchmarking thing. It was either from that Stack Overflow guy or maybe it was Adam. I don't remember. But
Makes sense.
yeah. So like they're saying like, okay, like before we tear down the process, we just call this suspend the E. I mean, we already suspend the E in some code pathing shutdown anyway. So they want to get like, oh, did this, like if I change to a newer version of framework, did the total allocated bytes increase or decrease?
Right.
Although in a benchmarking scenario, would this I'm trying to say, would this even matter if you call it before you start any work associated with the thing that you're measuring, and then you definitively know that the thing you're measuring has ceased to run anywhere, and you call this again, you're going to get a fairly accurate number, right? If nothing else is happening in the background, like you're not doing any other background work.
That's true. I think if unless you you have some background work, I guess that's what people are saying.
Right, but if you have background work and you're benchmarking, you're doing something wrong.
Yeah, I agree.
Yeah, I mean, given the comment that says, passing true has a at least potential significant performance penalty, I think that I would say that we should go ahead and have it default to false, so somebody who doesn't understand the consequence gets the less impactful thing. Like if they're just like, oh, I want to go like log what this number is periodically.
I mean, you can imagine this used in non-shutdown, obviously, right? If I have like different, like if I were to write like a compiler, like I have a compiler benchmark, it's very possible that I want to, at each phase of the compiler, I want to say like what is the allocated bytes. So,
but I think having the default be false means if you don't know what you're doing, you get the thing that's nicer on the rest of the runtime, and if you think you know what you're doing, then you can pass true.
Yeah.
So,
Sounds good.
I would default it to false.
Yeah.
I would agree with that.
It just signals which way we expect someone who doesn't know what they're doing to, which value they should pass.
And just to check, is this expensive, or is just like if precise is false, is this just fetching a value from somewhere, or is it actually doing work?
Every managed thread has this field stored on the thread object.
So this is iterating through all the threads and summing it up.
And you need to keep track of the dead threads. Yeah.
All right, so I just wrote this.
All right.
Based on what we just said. Everybody agrees with that?
So should we like edit the first comment to reflect this, or what is the?
So normally, you're free to do that. I mean, usually, like after the feedback has been submitted, I don't expect you to update the issue to match that.
You do not.
I do not. Like, I mean, if you update your source code to match that, that's fine. I mean, if this is the last comment on the thread, I think that's fine. Otherwise, it's just busy work.
Sounds good.
All right.
All right. Thank you.
All right, so one down. So now I think Tarek wants to look at index range because we want to get this one done soon.
Thanks, Melody.
Thanks.
Because we run out of time for this round. So I think Jeremy knows that. So basically what we have done is we have changed the way the C# compiler binds to index and range. Meaning, originally the goal was that index and range is just a normal struct that the compiler binds the syntax to. So if you want to index into a collection that uses the range, then the collection physically has to provide an indexer that takes range. And in the same way, if you want to use the head character which binds to index, you need to provide an indexer that has that takes index. Unfortunately, there's a couple of downsides. The biggest one being that sometimes you just can't add members. Like, for example, let's say you want to use our read-only interfaces. Well, if they only have one indexer. So the compiler team basically came up with a way where instead of doing that, the compiler effectively emits the code that takes the length/count property and effectively just does the right thing. So now that means we no longer need to expose that many indexes that take range or index. So what this basically reflects is, the proposal that I hacked up yesterday of given the entire API service that we did for range and index, let's go over that and decide whether there's a few things we want to remove. And so this is basically that. I think there was some feedback from Tarek already on the thread, so I think this proposal is no longer, the most up-to-date one, but I think I can probably edit this as we're
I mean, I think
talking about
the comments all basically came down to, do we need those remaining slice index methods that you left in?
Yes, the only reason I left them in is basically So my understanding is that the compiler, let me actually get this right. So yeah, so the compiler will not do the lowering for index on arbitrary members, right? So if you want to slice using index by itself, then you just have no way of doing it unless we leave the index in.
Well, no, you do. Mem open bracket hat 35 ... close bracket.
Oh, okay. You're basically using range rather than index. Yes.
Right.
That's fair. Yeah, I don't have a strong opinion. Like, I mean, if I think that works for me. So that would mean, let me just quickly do this. You would. Oh, this is not inconvenient at all. All right, I just updated it. Should refresh in a sec. Was it done? All right, so that means in memory we kill them all. Memory extensions I left in, but following your rationale, Stephen, we could probably get rid of the as memory that takes index and only have the one.
We could. I don't have a strong feeling about it. I think it's actually. I mean, yeah, I don't have a strong opinion. As long as I think there's a difference between going from 0 to more than 0, but once we're adding 1, adding 2 doesn't seem like a huge deal.
Yeah, that's fair. So then for string, basically, I killed the one that takes substring. Following your rationale, you could do it in our.
We would also kill the one that takes range.
No, I thought that's the one we need because the compiler will bind to that one.
No, the compiler bind to 2 inches.
What?
2 inches. Substring takes 2 inches.
Yeah, it'll bind to the one we already have.
Oh, got it. Got it. I think, yeah, that was the thing that I missed. Okay, that makes sense. Sweet. So then we actually done something.
So the only remaining issues that Stephen raised about get sub array, should we keep it in the...
Yeah, so honestly, I have not a strong opinion. I think the reason why we put it under compiler services was because we didn't expect anybody to do that directly, and having that method seemed weird on an array. But given that we now have this generalized method, yeah, actually having a static slice method seems fine to me.
I don't have a strong opinion either. I just wanted to make sure we revisited it because I realized it kind of slipped through without much attention paid for it because it was, just a little helper for the compiler to use.
Yep.
So I just wanted to make sure we talked about it, but I don't actually have a strong opinion.
We can't make an extension method because, yeah.
Also, the problem if we change it, so it will be a breaking change for the compiler. So if somebody using mix and match between the compiler version and the libraries, it would be a problem.
To be fair, that's true for this entire change, right?
No. Yeah, I mean, we would add the new one, and then once the compiler change propagated, we'd remove the old one.
So is the result of this that we've changed how we feel about having range indexers in general?
They would still be needed on types that don't have a slice method, except for string and array.
Well,
for ones that need a complex slice method, right?
Yeah.
Like tensor types.
Yeah.
Well, basically, so there's two things, right? The biggest problem was that requiring the indexer is very unfortunate in cases where you have interfaces because you fundamentally can't have an extension indexer, right?
Yeah.
So binding to slice allows you to say, well, we could add slice methods for interfaces in the BCL, and then you can index into them just fine. I think in cases where you have a concrete type like list of T, the idea was, well, it's nice if we don't actually have to add them to begin with, because we it's just nice if indexing with index at least just works fine.
Yeah.
And then for range, the problem is that the compiler can't really decide what to do for you because you have to decide what type to create, right? And so like somebody has to provide that functionality, whether you do it on the type or whether you do it as an extension method is largely up for the concrete types.
Right, and I guess on one hand I have a little bit of heartburn with putting extension methods like slice on list of t unless those extension methods offer a projection over that list of t without making a duplicate. Because normally when you see the word slice, you think cheap or free.
Right.
Normally.
Yeah, unfortunately, we're already down that rabbit hole with array and string.
Yeah, but we don't have slice methods there, right? We have substring.
Well, but they're going to show up in the from a usability perspective. They're going to show up the same way. Array, open brace, dot brace.
Yeah, I'm saying for somebody who's not using this compiler syntax, like if they just see a slice method off of list of t, like they're probably reasonably going to think this is a free view over it.
I would think the same thing about the compiler syntax, but that's just me, I guess.
Okay. And that's
I would honestly say the compiler syntax, I would even more agree that because it's an indexer, right, you expect historically that properties are cheap and indexing is 01.
Yeah.
But when I talked with Mats about it, basically the conclusion was, well, ranging, I guess this word is new in this thing, and just have to educate people that, well, if you get first of all, you have to allocate something usually, right? Even if it's a view, so it's not like super cheap, like an indexer with an int would be. And then the question is whether you get a view or not depends on the type, so you have to check. And
excuse me, for me at least, I've used this example a few times, but the thing I think we're going to have to be on the lookout for in Core CLR and Core FX, and we'll probably even want to write some kind of analyzer for it, is if someone writes like span of char s equals array sub dot dot.
Yeah.
That will allocate copy an array, but it's not particularly visible in the source.
And I imagine like it's off the table to make this particular syntax return a span as opposed to a string or an array.
Well, our previous argument was that it should return whatever it's indexing.
Yeah, so I think for array, I think I can go one way or the other. I don't have super strong feelings on array, but on strings, I don't think we get to return span. Like they're so not usable for people, and like string is just so much more useful that I think in common code where people just don't care because strings are relatively short, most of the time the copies don't matter that much, and people do substringing today like left and right, and like you just give them a way to do it in a more compact syntax.
Yeah, and if people want to have a span instead, if we're going to provide an analyzer for catching places where we're doing this in the framework, we could probably provide an equal analyzer that says
insert as span somewhere.
Yeah, put as span and handle it that way.
Yeah.
Yeah.
But then isn't the point that people want to use a nice syntax though?
Yeah, you get well, there's two pieces to the nice syntax. You could still do as span and use range. Like that's what those memory extensions were. So you could say as span open bracket dot dot close bracket.
Yeah.
And that'll work fine. The argument for returning the same type, which is pretty much locked, is however I feel about it, which is I don't like it. But it's whatever you start with, you end up with. And if you want something different for performance reasons, well, then you know what you're doing, and you write the few extra characters.
Sure. I mean, if that argument's already been beaten to death, then it's already been beaten. So.
I mean, that's where we landed in LDM. I mean, to be honest, this is not a feature area where we have seen a lot of custom value one way or the other.
Right.
So I don't think either side can, say that based on customer data that's the right or wrong decision. But I mean, internally in BCL we have just very different requirements, and we know that, right? So like some things that we like as syntactic sugar for the platform may not be great for the customer, and vice versa. Like that's. So anyway, so I think then this is the one. So to be fair, though, this list here I got from, I don't know from where. I think it was an issue that I think Tarek or somebody else opened. So I assume this is complete, but we should probably do another pass on making sure that we don't have any other APIs lingering around. But other than that, I think we established the principle here. So it should be rinse and repeat if we go down the other side.
So for get subarray, did we want to leave it where it is, and it's just a helper the compiler uses, or do we want to move it? I
agree with you. We should.
Curious whether.
Yeah, let me actually copy and paste this guy in and make that clear.
Yeah,
and then the question. Sorry, I was going to say I don't know. We never discussed this with the compiler team, but we need to figure out whether it actually takes two ints or whether it takes a range.
We are going to special case a string anyway, right? I mean,
I think so. Following Jared, he was the one that said earlier that he doesn't mind special casing string and array, and I mean clearly the compiler today has to do work to special case that gets up array method somehow, and whether they special case it for this location or another one, I think is largely irrelevant.
Well, what about things like array segment? I guess we would just add a slice method there.
It was the lowest.
Oh, it already has a slice method. Never mind.
If I think runtime helpers should largely be reserved for things that you can't do in regular C# code. A lot of the times they're currently things that are actually implemented in the runtime with special case support. But this sounds like it's just creating a new array and copying the existing subarray into it. So that's trivial C# code.
There are some considerations there, especially because arrays have weird pseudo covariance. So, and I think Steve actually just checked this in last night, so I'll let him talk about it. But, yeah.
Yeah, I just had improved some stuff that Tarek had done previously, but it does. It tries to ensure that if you give it, if T here is object, but the actual array is a string array, it still allocates a string array rather than an object array. Things like that.
Yeah, but that seems like things that the string class already does. So, or the array class already does rather.
Yeah, it's certainly writable in C#.
Right.
But it's not just new T.
Right.
Yeah.
Right.
Yeah.
It's not intuitive. That's
So
you have to write
one thing I heard was you could do asspan and then bracket dot dot bracket, but isn't that counter to our guidelines that don't use asspan dot slice, just do asspan and pass in the slice arguments because it's faster?
That's what that is.
As span open paren, open square bracket, stuff, close square bracket, close paren.
Oh, because you would be passing a range to asspan.
Yeah.
Yeah.
Oh, okay, perfect.
Perfect.
Okay.
Yeah. Yeah, so I wonder if instead of slice, we would call this like, copy segment. And then that way we're avoiding the notion that the word slice is a cheap projection. We're saying the word copy, it's visible, and the compiler can special case it.
You're talking the array case specifically, correct?
Yeah. Because string already has it, it's substring.
Yeah.
We already understand that like, substring makes a copy, it's the thing it does.
Yeah,
Subarray would be the equivalent thing here, but we've never had a subarray, and it feels weird.
Yeah, and subarrays sound like my first intuition if I heard get subarray would be it's basically doing a slice rather than incurring a copy. It might be doing interior pointer magic
or
with
it's going
the array.
from T bracket 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 to T bracket bracket or something. So,
to be fair though, like if you name the method slice, your argument does not get better, right?
Yeah. So that's why I said copy segment.
But are we okay with this breaking change for the compiler? Because I hear that this would be very bad.
What would there be breaking change? Everything else
when you say breaking change, I mean this is new in this release, and we can mitigate it just by saying we add the new one, we wait a while, and then we remove the old one.
Yeah. Yeah. We don't have to move it in the same commit. We just want to remove the existing one before we ship.
Yeah.
Yeah.
We don't want people running off of beta things for the preview builds and then mixing them with RTM builds.
Yeah.
So.
But I mean, we've done stuff like this before, where we just have them exist side by side for release.
Yeah. So here's what I just wrote. We should bet this decision with the compiler team for sure. They may have strong opinions on that, but I think it's in the spirit of what the feature is, right? And to me, the fact that it's named, that it's not an instance member, but it's a static member, it's special cased in the same way that on string it's not slice, it's substring, right? Like it's both are core types, and it kind of makes sense. But I think the end result feels a little bit more self-consistent because array is full of static helpers. There are no instance members on Z arrays realistically, so that's the way it is.
My comment was we should call it copy segment instead of slice.
Should we call it copy to match the other ones?
So I wouldn't do that because the argument that you're bringing up holds for everything we do, and in all of the cases we accepted that it can be a copy, right? So how is this method special?
Because it means that array.slice and array.asspan.slice don't have, like, arrays are implicitly convertible to slices.
Yeah, but the same is true today. It's substring dot.
But it's not called slice.
What?
Substring isn't called slice, it's called substring.
Yeah.
I'm saying we should not use the same word we use on the span that it's implicitly convertible to, especially because once someone's using var, you really can't tell what the code's doing.
Sure.
Yeah. So I mean, granted, this is a static method, so you have to call it using a different syntax, but I still think that we should not use the word slice, given that this is implicitly convertible to span.
If only somebody would write a design guideline which says slice shall be allocation free.
Well, it can be allocation free, but it could be a view.
Yeah.
But I think this is more like the question of like, how do you think about the compiler feature in general, right? Because the compiler feature just says, I bind to a method called slice. So you have no choice but calling it slice in all other cases. So that's why is array special?
Because array and string are...
Yeah, but are you basically saying that any range indexer should always be a view? Because really that's not the case.
Well, it's...
No matter what you call it.
I mean, we control the APIs that developers use when they interact with the framework in the runtime, correct? Like if we create an API where it's likely for developers to do something that has performance implications that they weren't expecting, then that means that we presumably have not done our jobs correctly. So
right, but I mean, to be clear, I don't think anybody called slice. People will just take an array, open bracket, and then the index the range.
At which point it doesn't matter what the method's called.
Yes.
Correct. Yes. That's what I'm saying. So like I think the argument that people have to be aware of it, I think, is already the case, no matter what we do.
Well, no. So that means when you see the word slice, it should be the good word and not maybe the bad word. So we should not use the good word on a thing that no one's going to see.
This is our opportunity to say the word slice in the framework is O of 1.
No, because that's what I'm saying. You can't do that unless you're willing to say a range-based indexer shall always produce a view.
No.
But how would you do the I-read-only interfaces then?
So what we're talking about is just the word slice should indicate.
I understand what you're saying. I'm saying if you
O1.
want to provide an indexer that takes range, and you can't add the member because it's an interface, you must provide a method called slice. You have no choice. Right. You must name it slice because that's how the compiler binds.
So my argument is
that basically means, given that you said slice shall mean, it's always a view. That means for framework types, ignoring string, because it's a special case, it always must be a view. That's effectively what you're saying.
Slice.
I'm not saying that's bad. I'm saying that's the logical consequence.
Slice should be an O1 view on things that are implicitly convertible to span.
But that's I mean, to Emo's point, that is no longer what it is.
Like
the fact that the compiler requires the use of the word slice on whatever type you want to slice is no longer that.
Fair enough. If that's what the feature changed into.
I mean, is that locked in stone? Like,
well, you could talk to the compiler and say use a different word than slice. I would argue. Like, you just have to come up with one.
But at that point, we also then have to go and add that thing to span, array, segment, memory, string, all the other ones.
So that's a good point, actually.
Can we at least make all of those?
Or
so
if it does both.
Sorry, Jeremy, go.
Or if it does both, like it prefers slice and then falls back on the thing that actually allocates.
If we did call these methods slice, could we at least mark them at irreversible never? Because the compiler is going to find them either way.
Sure.
Just like get pinnable reference, we made all of those methods at irreversible never.
Which one are we going to make editable browser never?
Anything that's called slice that isn't an O of 1 projection.
We haven't added any of those yet, right?
But presumably they would be added to I-read-only list. And so
we're about to add one to array.
Right.
Yeah.
Well, it's a static, though.
Yeah.
I mean, to be honest, like, I could go either way. Like, I think putting editable browser on it doesn't save you that much, in my opinion, because you still have to explain the concept to someone. Right?
If we're gonna put editable browser on it, we may as well not move it off of runtime helpers.
Yeah, I would agree with that too.
Yeah.
You know, I think maybe just keeping slice is fine, and if people really want to differentiate in the future, we could have something like get view, because that's what you would need to do for something like list of T anyways. Because returning a span of a list of T doesn't make sense, but returning a list view for a list of T does. So maybe slice is just fine. And
no, that's reasonable.
Well, you will still have to provide the slice method anyway, but now you do two things.
Do you think it would be that hard to provide two? I mean, to have them seek for two, like then you can have copy and slice.
I think the hard part is coming up with a name for it. That
Well,
makes
If it
sense.
seeks for 2, that means there's a breaking change. There's a looming breaking change that's very hard to reason about, because if you add a method that has the higher binding, then now it's a compile break for everybody.
So also to be clear, like if you look back, the reason,
Sure, but you have that already with a bunch of things.
yes, but it's never great. Like, I mean, they try to limit these cases, right? Like slice today, for example, is not really a thing anybody uses.
Well, you use it if you're coming from other languages, basically.
Right. I think at some point, like Jared did a scan on GitHub and like see how many people actually use slice in .NET Code. There wasn't that many.
Yeah.
I think the question is just, if you look back, what was the motivation for this feature? The motivation for this feature was twofold, right? Like some minor perf gains, but more importantly, we don't have to sprinkle a bunch of APIs through the framework, right? If we land on design that kind of requires us to add 2 methods in sync, that seems pretty bad.
Yeah.
I would say that kind of defeats the point of this feature, which was let's have fewer APIs and let the compiler just bind to them that are already there. If we don't like slice, then that's fine. But then, to Stephen's point, you would have to change the APIs on span, which I don't think we want.
I wasn't suggesting adding both. I was suggesting having either or. So like having them do the binding, but I can see the argument about getting precedence bumped. You have both of, if you actually have both of them implemented. But
how about this? So I can take this section out of here, and we file a separate action item for this, whether we want to move the method or not, because I think it's largely orthogonal to this discussion here.
The runtime helpers method.
Yeah, and then we can have the conversation with the compiler guys again if you really want to do that. Let me just quickly find an issue. Consider. Oops.
I guess if there were critical mass to accept this proposal the way it were today, like I wouldn't.
I just think it's taking the crap that Steve's concerned about more common.
Oh, it is.
Yeah, but we're going to have some APIs that are like that, and we've got plenty today, and I think the answer is we need to make our existing analyzer repo more public, more available, and encourage people to actually write analyzers for cases when they hit things like this.
Yeah, but if the code that you're just naturally inclined to write is flagged by the analyzer as you're doing it wrong, like that just doesn't sit well with me.
Well, so speaking for someone who cares a lot about perf, the only types that I really think this is going to be an issue for is array and string. Everything else isn't implicitly I mean, most other things aren't implicitly convertible to span anyway. And the whole design for C# has basically come down to you get out what you put in. And so anyone using this feature on their own type, regardless of what type it is, they're going to be using slice to mean what you get out what you put in.
Right.
Those things generally won't be convertible to span.
Yeah. Right. So my reason of not wanting to use the word slice on array is if we're already special casing string, we can special case array, and those are essentially the 2 types that are implicitly convertible to read-only span.
I don't care what name we use on array.
Right. Well, that's why I was just trying to avoid slice there, because then it's when you're working with a thing that looks like an array, it's obvious what slice means, and it's much more contextual of what slice means. Given that it's static, it's less relevant, but I'm trying to be slightly purist, but not to the point that I care anymore.
Well, and you already have the case with string and array that if you just call like string dot something, it's going to operate and return a string. You have to do as span to get the span semantics. So maybe that's consistent with the existing logic there.
Well, but somebody, maybe it was you, brought up earlier, like read-only span of char foo equals my string bracket. That was Steve. Okay.
Yeah.
Yeah, like that.
Concerned
that
with the feature.
We absolutely need to, at minimum, have an analyzer to track that.
Really, what it means is, if we were designing this and span at the same time, I would say we should not have any implicit.
It's generally the solution to overload problems.
Int shall not be boxed without writing a custom conversion operator.
So we have time for 2/3 of one more thing.
Yeah, so I thought the issue, I think the other one we can consider API approved, so that gives us at least something to work off of.
Yep.
And of course oh no, it's actually on the screen. Here we go.
Any of these fast?
I think the hardware intrinsics have generally been fast because we've said their hardware intrinsics go ahead.
So we have Friday, we have, I think, Wednesday we have a JSON one already.
Yeah.
So that's
Vex, SIMD, move, 0 extended,
Yes.
to D-word?
Yes.
Wow, okay.
So for these APIs, we encountered two subtle issues with it. The first one is that the return type, we decided for 0 extend to return unsigned and for signed extend to return the signed type, but that doesn't match what the native signature does. And it doesn't match the normal C# semantics for 0 and sign extension. So we said we should convert these to always return the sign type to both match the underlying native intrinsic and the normal C# convention for 0 and sign extension. And then additionally, we said we need to break out the memory the memory load versions into their own methods because they have different semantics than the implicit signature that takes a vector.
sorry, the first one I understand, the second one I don't understand.
So basically, for most APIs, we don't have explicit overloads that take a pointer. We just have them take the vector type, and then internally the JIT will say, if this vector is coming from memory, then emit the more efficient memory encoding. Mm-hmm. The problem with this API in particular is that it doesn't read 128 bits, so you can't do like SSE load vector 128 and expect the more efficient encoding to happen. Instead, this operates on the lower half of the register based on whatever size you're working in. So the lower half of elements. So the lower 8 bytes or the lower 4 shorts, lower 2 floats, etc. And so we need to have an explicit separate overload that takes a pointer to make it clear the semantics differ and be able to emit the efficient memory encoding.
But they all forward, right?
They're all what?
They all seem to forward to another overload straight.
No, they're recursive because that's how the JIT implements intrinsics.
That way, if you call them through reflection, the JIT can replace the implementation.
Yes. It's fancy magic to say.
I don't want to know that. This goes back to what Richard earlier. I wish he would have lied to me. All right, so I mean, similar to crypto, I don't have many objections. It seems reasonable to me. The names seem to be in line with what we decided earlier. So unless somebody else has a problem with that, I will consider this one at least.
So the only changes is that we're changing unsigned to signed in the return type.
And breaking out the overload, so you've got short. So
can you scroll down a bit?
Yeah.
This one is a bit more of a mouthful here.
But it's the same pattern.
Right. Yeah, and then breaking it out into explicit T* overloads.
Got it.
This is what that look like, right? So it's decently sized.
Yeah.
And these are all unaligned, correct?
Correct.
Okay, because normally we put the aligned suffix, I think.
Right.
Okay. Okay.
Stephen?
Sorry, I was muted. My eyes glaze over at all these names anyway, so my care factor is low.
That's what I thought. All right, that means API approved, API ready for view removed.
Yeah.
Then we remove blocking partner. I probably should have added API approved, right? All right. First one gone. Second one.
This one should hopefully be easy as well. We already reviewed and approved this, but I ended up finding there was a thing that we didn't cover. So this issue was basically the ordering of the existing APIs are confusing. They're currently compare equal ordered scalar, and that can imply that we are doing that the scalars themselves are ordered versus us doing an ordered comparison, and we said we should reorder those to be...
That doesn't help. That doesn't help when you say it like that. You mean swap the words, right?
Yeah, yes.
Which also doesn't help when I'm realizing that.
There's also an enum that can an enum for the 256-bit overloads because they've got significantly more complexity, where there's similar word ordering constraints, and I just want to basically wanting to double check we're fine with also reordering these. The one difference is that there's some additional contextual keywords here, so like non-signaling and signaling versions. And so we basically just need to decide where the order, if it's still going to be ordered equal non-signaling for the same order we had decided previously.
Okay, so last time we said compare ordered scalar XXX and compare unordered scalar XXX.
Right.
And now you're proposing...
Right, so we've got an enum which doesn't have the compare prefix, but it still has all the other keywords. So it's got the XXX keyword, it's got the ordered, ordered and unordered keyword, and then it's got signaling and non-signaling as well. And want to determine if we were going to keep those ones the same, or if we were going to reorder it to be ordered signaling less than, or ordered less than signaling.
I mean, in general, I would try to make these consistent so that when you get the rule, that they apply uniformly, right? And it seems like largely you have to make up your mind on like what the rule is.
Right. And so I think
which I feel like you're probably better suited to make that determination.
I think the most logical ordering that's consistent with how we ordered the other ones would be ordered XXX and then signaling. So you might have unordered equal signaling and unordered equal non-signaling.
Right.
Generally, though, we put the verb at the very beginning, where the verb is compare, or the operation.
Right, but we don't have a compare verb here because it's an enum that's passed to the compare method.
Okay.
Yeah, so it's basically the noun, not the method name, right?
Yeah.
That works for me.
Okay.
I agree.
So then it's, I don't know exactly what I'm approving here, but
so it would be
because I don't see an actual proposal, but
right. So the ordering proposed would be we match ordered XXX signaling.
Did you write this up somewhere, or?
It's at the bottom of the method, isn't it?
So
it's at the very bottom. Of the
I forgot to put the actual proposal.
No, but I think at the bottom of the issue you have an example.
That's the example of how they're currently ordered.
What you want to change.
Yeah, and we want to change it. Ordered XXX signaling. There we go. Commented.
Damn, I was just about to comment and say you need to include it. Alright, so... Okay. Alright, now then... Yeah. God, we even have time left. I can't believe it.
But the one Boolean thing. For the clarity and control or whatever. Yes.
Before we go on to that issue, I had a follow-up question on the GC issue.
Oh yeah.
We have get allocated bytes for current thread, and we just added get total bytes allocated. Should we rename it to get total allocated bytes to match?
Yes. Bytes is the unit. It should be a suffix.
Sorry, which issue is that?
Yeah.
No, I meant like the one that you just said, the other one that we approved before.
Yeah, we just approved it like half hour ago.
It's me.
You mean when did the get allocated bytes for thread come in?
Yeah, because that's the one we need to change, right?
No, we need to change the new one to match the existing one.
Okay, no, I'm...
Add bytes to everything except we didn't cover the new method names.
No, so the method has bytes. It's just it gets total bytes allocated. It should be gets
get total allocated bytes.
Right.
Okay. Okay. Yeah.
Yeah.
Another ordering.
Yeah.
problem.
Just transpose.
prior art, aside from the fact that the unit makes more sense on the end. The prior art was that core kit.
Sorry,
Scroll to the
like,
bottom. Yeah.
let's go. You can see it, but like, we have get allocated bytes for current thread. Should get total bytes allocated. Total allocated bytes.
So we just approved this API, right? Just swap the bytes and allocate it to match the API existing one.
Get total.
And Mayoni already agreed.
What did she say?
Yeah.
Sounds good.
Okay.
All right.
Middle one. Okay, so we started talking about this previously in a meeting where we ran out of time. So based on talking with Christoph Goina, who's the only stakeholder right now outside the JSON library itself, he thinks that what we had was too many knobs and switches and too complicated, and that we should pare it down, which is fine. So he, in fact, recommended using the word. All right, so the scenario is you have a JSON element. JSON elements come from a JSON document. JSON document is disposable. That means JSON elements are transitively disposable, and there's nothing you can do about it. So if you have one and you would like it to live longer, you need to be able to make it live longer. So this is where this new method is coming in. Originally, we proposed detach.
Yep.
That has some. Is that a destructive verb or not? So based on Christoph's recommendation, clone.
Yep.
And so that's the easy part of this proposal.
Can I ask a question on the easy part of this proposal?
Sure.
When does JSON element expose a parent?
No.
Okay, so there's no way to get back from a JSON element to the document that it contains that contains it.
You can't get from an element to the document, or you can't get from an element that's a member of a larger object to the thing that it was contained in.
Okay.
You can only go, let's call it down.
Yep, got it.
So clone in particular will clone the current sub element. So if it's not the entirety of the document, it will make a copy of the smaller thing for GC reasons. And then the Boolean is to expose, is this already in a state where you can let it live for a long time? It won't indicate if it's minimal, but it will indicate that it can't be disposed. And the best answer I came up with is persistible, once we didn't have the verb be called detach. So, but I don't know that I like this.
But basically persistible, like how would I use it? Because basically you can always call clone, and worst case it does nothing, right?
So you can always call clone, at worst case it copies.
I see. And
at best case it does nothing.
So and you're saying that's cheaper than...
So clone is always, if the output of clone you can always save indefinitely. It's now GC semantics.
So essentially, let's say if you want to store the JSON element to a dictionary, you say if it's persistible, store it, else store the clone.
So why would it not just always call clone?
I think you would just call clone and just store the resulting thing.
You could, but if you knew that you already had the outer object, you would know that you don't need to call clone on the inner object, because that would actually be copying a bunch of segments over and over again.
Well, why would it create?
Well, why wouldn't clone just return itself if it's persistible is true?
If you had 100 meg payload and you only call clone on on the word true, do we really want to hold 100 meg around as the GC reference? Or do we only want the 4 bytes of the word?
I guess I don't understand. I would have assumed that clone would have changed the internal structure to make it more of a tree.
So clone is copy all of the bytes from the original payload, because we maintain them as they were because of, we have the method get raw JSON, which means that we need to keep it in the original form. And so it needs to keep it, at minimum, its sub portion of the object alive. The question is, does it also keep any outer portion alive if anybody's already called clone? And both answers are valid, and it's hard to decide. It's hard to ask someone, did they mean be the smallest possible clone, or simply don't be disposable?
Isn't this the problem we normally have with clone as well? Like,
Sure.
is it shallow? Is it deep? iClonable is terrible. Never use it.
Well, this isn't iClonable.
Yeah.
And this is deep. It's just a question of.
Yeah, I think clone as a name is problematic. If we're calling it is persistable, it should just be persist.
Yeah. The question is like to the original thing that Krista brought up though is that a destructive operation in the original instance?
Right.
Persist kind of implies there's a side effect.
We can get rid of the boolean, and we can say if you want to store it, call clone, and be smart about when you want to do some things. You just can't ever prove that a thing is a something of another thing.
Yeah, I still don't understand how the property helps you with the problem though, because I mean, like, if it is disposable, then it means I have to copy 100 megabytes worst case, which I may not need, right?
If it is disposable and you're looking at a thing and you want to maintain this state, you have to copy whatever the state means.
Right. So that means like so it seems like the problem is that clone may copy more than you needed, which you can always run into regardless of whether you create a property or not. Right?
But if somebody passes me a JSON element,
yes,
and it's already in its persistable state, why would I call clone?
No, clone should be no op then. It should just return itself. Like imagine this thing is internal, right? And then clone's implementation says if persistent will return this, otherwise it will copy.
We can do that. It just means that that if you wanted to shake off all the outer portions of an object, because you're now scoped down into a smaller view, that you have to do a lot more work to do that, and that's fine.
Sure, but how do you know if there are too many states here to be represented by a single Boolean?
Sort of. Which is
so there's always going to be. But what if you wanted to? Like, I mean, once you call clone, like if you're operating on a cloned thing, is persistable is going to return true, correct?
Yes.
Yes.
Right. So, but you don't know at that point whether it's because you were part of a larger cloned thing or because you were your own cloned thing, right?
Yes. That is true.
I see.
So then, it doesn't really help you.
Yeah.
Fair enough. So we could just do clone, and the answer is if you want to store something, call clone, or have knowledge that it's okay for you to store.
Yes. Or just make clone a no op. And then we add the other feature later.
Well, that's the if we can say that clone is no op if it's
yes,
and then we can do we can make a minimal clone later if Christoph can play.
Yeah.
Oh, so clone will not copy the whole thing?
Clone will copy if pretend we have is persistable. If is persistable is false, clone will copy exactly what it needs to. If is persistable is true, it says return this. So multiple objects from the same 100 meg payload, I'll keep the same 100 meg payload alive. If you only kept one thing out of the 100 meg payload, it's a very expensive. But why are you persisting a Boolean? You should only persist things that are bigger than that. And then this still solves what I understand the serializer's need is it wants to be able to create the document and return an element that's not bound by dispose anymore.
So why not always call clone and always trim? And not have the is persistable check.
Do that too.
Yeah, I would like if you have evidence for that you need this, then you can add it later if we have to. For now, I would just leave it at clone and then do trim later if that actually shows up. I mean, it's a general problem that we have, right? Like if you store an object reference and that is a potentially large tree that you hold alive, like I mean, this is not specific to this.
I guess part of the problem is if let's say you're storing multiple objects, multiple JSON elements,
right.
Now you have multiple copies around. You have each clone. Like I have an array.
Well,
I'm gonna clone each of them.
I think Emo's recommendation was clone says if it's already detached from the dispose, it returns this, and if we have need for the small version later, then we have a new method called trim.
Yes.
Okay.
And then you have clone and trim, and you call whichever one you care about.
Yes. Okay. And I think I mean there was a similar problem, right? Where I think there was the Java problem with doing substringing by basically doing span views. It's like you keep a 4-character string around, but it was originated from a 4 gig document. Well, the 4 gig document is now around forever, right? And they solved this problem by saying, well, maybe we shouldn't do that at the beginning. But you could also imagine a smarter system that just detects that and then basically dynamically compacts the string and removes the other one, right? If nobody else holds it alive. But like in our case, like you could imagine that in this case, I would assert most of the time somebody up the chain knows what's going on, and you carve out like a subtree from the document first, and then you just say, yeah, each of the nodes within the document can only keep the document around, and that's fine, and then you just keep that guy around.
The biggest internal use that we have is always going to be cloning on the root element, which is the serializer doing a sub parse based off the existing thing, calls clone, and then emits that as the I didn't know what to do with this chunk.
Yeah, I mean, like
Jeremy, this replaces all the detached stuff that was put up as PR previously, right?
Yes. So
okay.
the PR will get a lot smaller now. Actually, it'll probably keep all the stuff that it had. It'll just all switch to internal, and then the tests will get smaller.
We did well. All right, thank you guys. Then I see you tomorrow.